Alright, good morning everyone. My name is Jing Vergara and I'm a principal engineer at Salesforce.com. And today I'm going to share my knowledge with regards to VM image baking and deployment in Spinnaker. So one of our values at Salesforce is to multiply ourselves. So one way of doing that is sharing the knowledge we've learned. We've been doing this for about a year now, where we started, hey, there's Spinnaker, let's figure out what it can do for us and what are the different features and capabilities. So my assignment at that time was to figure out everything about VM image baking and deployment. So hopefully throughout these slides, each one will bring something home back to your organizations. So these are what we have for today. I'll be sharing some baking and deployment tips, and then some best practices we learned along the way, some troubleshooting guides, a couple of tips, and then some contribution ideas with regards to VM image baking and deployment in Spinnaker. All right, so when we think about baking, right, it usually starts with a base ingredient, like the flour, right? And then we mix it up with the eggs, salt, sugar, and other things to form a dough, and then bake it, right? In the VM world, we start with our base ingredient, which is the base OS. And then we mix it up with our other ingredients. We have our binaries, our libraries, the application, some data files, compressed files, and other agent RPMs that we want to include in that VM. So we bake that VM, we create a snapshot of it, and it gets persisted into an AMI store. And once that image is ready, we can use that same image to spin up multiple VMs. We can talk about tens or hundreds, even thousands of VMs from that same image, right? So it's one of the immutable artifact patterns that we all like to do to avoid configuration drift. So behind the scenes, Spinnaker has multiple microservices, and Roscoe is the microservice that does all of this baking. It does two things, one for the Kubernetes world and one for the VM world. In the Kubernetes world, we have the Helm charts that basically just gets converted to the Kubernetes manifest. So for those who are not or do not know what Helm chart is, think of it as just the templatized Kubernetes manifest, and then for the particular deployment, it just becomes specific. And then in the VM world, Spinnaker or Roscoe uses the Packer templates and generates VM images out of it. So Packer is an open source industry standard tool that is being used to generate VM images for multiple platforms. So it is composed of three things right here. I'm just talking about the basic. It also has other components, but I'll be focusing on these three. So let's start with the builders. The builder is what kind of platform to use to generate those images for. It supports about, I think, around 35 now, and the list is growing, right? So, for example, we have OpenStack, GCE, EC2, Azure, etc. And then the provisioner is what is being used to actually customize what's going to be in that VM. So you can execute shell scripts, or Ansible, Chef, or Puppet, and again, there's about 18 provisioners, and again, the list is growing. And then user variables is a way to further configure those templates. So if you want that template to be more configurable, then you add variables in it. So here's an example in Spinnaker, one of the default Packer templates that we have here. So you'll see first, that will be like the list of variables that can be used inside a template. So for example, you have multiple baking regions. Then you can customize it by wherever that Packer template runs, right? You can see that subnet and the VPCID, all those will be derived from the environment variables. And the rest can be passed in as command line interface within Roscoe. And then here's an example of the builders and the provisions. One thing to note, in Packer, builders is actually an array of builders, which means it can use multiple builders at a time, use the same set of provisioner stats, and it will generate all of those images. However, in Spinnaker, you can only use one Packer template for a builder. So that's just one difference that you have to take note of once you start using Spinnaker for image baking. All right, so people might be wondering, where does baking and deployment fit in the full CI/CD lifecycle? So here is how it goes. So first we have our developers on the right side there, creating their code, committing it to Git, and then creating a pull request. Then on the left, we have our approver and says, okay, your code looks good, it's good to go. So gets merged into Git, and then it would kick off a job in your continuous integration system. Here we have Jenkins that will build all of those code into artifacts and store them into an artifact store. And then the event will generate a pub/sub event and can trigger Spinnaker based off of that. Just a note that this is just one of the ways that can be done. Like there are other things that can trigger Spinnaker. So Spinnaker, again behind the scenes, uses Roscoe, uses Packer to generate the VM images. And then once you're ready to deploy, uses those VM images to provision those VMs. So those last two steps, that's where baking and deployment fit in. All right, so next on the agenda is some tips. Like I said earlier, within Spinnaker, we have this default Packer templates that are available out of the box that can be used. And as you notice, we have one per builder type. AWS supports multiple, so you'll see a couple of AWS, while GC we only have one, Vergara we have one. And then another thing to note, in the AWS, you'll see like a multi Packer template and just the regular one. So the multi one is if you want to distribute that AMI image to other regions, or you want to share that AMI image to other accounts. By default, Spinnaker uses one account for baking, so if you need that VM image to be available to other accounts so they can launch it, you'll have to share it. So you will be using the multi-one for those cases. All right, another baking tip is Packer, again, is a powerful tool behind the scenes. So if you do not want to find an image during the baking process, to look for your base OS, one way to do it is to use filters in Packer. So this is something that just got introduced recently in 1.4 version, and we just upgraded Spinnaker to use the 1.4 version. So something new. So this one is something that was shared by Matt Daffler. Just a note that Spinnaker actually caches bakes for performance reasons. So if nothing would change, then it just uses, it finds that it hashes to the same key, then it's gonna skip baking and it can go to deployment. Because sometimes baking takes a long time, right? So it uses a certain set of keys. Just a note that if you have multiple bake jobs and they hash the same key, and then some of them are concurrently running, Spinnaker will terminate all of those concurrently running and make sure that there's only one. So just be careful about that one. And then if you're interested to use more of the Packer new features and they have a new version, here's a sample PR on how to contribute back to the Spinnaker code to upgrade the Packer binary. It's very straightforward, so easy peasy. So here I'll be talking about a few options with regards to multi-cloud baking. So for example, if you have Spinnaker deployed in one platform and you want to bake in another platform, then there are a few ways on how to go about it. So first let me explain what happens behind the scenes. So we have Roscoe there, which again is our microservice within Spinnaker that just calls Packer behind the scenes. First, it needs to create the Packer VM. So that's our base VM where we would want to run the provisioner steps. So what it does is it calls the cloud APIs to instantiate that VM. So you'll see there, if you want it in GCP, you call the GCP API. If you want it in AWS, it calls the AWS API. So once there's a VM, then the provisioner steps need to run, but for it to run, it needs to connect to that VM. So it connects using SSH. So you'll see there from Roscoe to the Packer VM here and to the Packer VMs there, all of those are via SSH. So that's actually the more complex part, because you need to make sure that those two things connect together. You have to set up that network and security setup. The most straightforward way to do it would be to just set up public IP addresses on where the Packer VM will get launched. But if you need it to be more secure, then you have to do extra steps. So one way to go about it is to set up a SOX proxy on the GCP side, because Spinnaker is on the GCP side in this scenario, right? That configuration is actually going to be the Packer template. So there's an SSH communicator as part of the Packer template where you can set that proxy. But what if you have stricter security requirements? You've seen our security requirements list. I think Edgar showed it earlier. So at Salesforce, we have to find all the things that we could make secure. So in this scenario, we have to set up bastion jump hosts on this side right here, right? And then we have to front end it with a load balancer and a Route 53 DNS record. We only want to surface the private IP, private DNS, and from that point, we want to use that private IP DNS, but to kind of mask that or NAT that, we need that VPN tunnel in between. So that's more setup. The VPN tunnel, you'll have to work with your NetSec group to set it up. And then, as the Spinnaker administrator, all you would need to do is set up all of these things here in your Packer template to set up that SSH communicator. So since it's out of the box, or it's not out of the box Packer template, you have to create custom Packer templates to get that going, which means, it was not in the original list I was sharing earlier, right? So create your own Packer template and drop it in that directory, the Profiles Roscoe Packer directory. However, these Packer templates actually have a limitation in size. Behind the scenes, Halyard actually converts them to Kubernetes secrets, and then it uses some annotations. So now we're limited to about 256 kilobytes, right? So if you have a long list of Packer templates or they're sizable, you have to do it a different way. You have to create an init container and or sidecar containers to load all of those into Roscoe pod upon startup. So if your Packer templates are pretty static, then you're good with the init container. So that means they get loaded upon startup of the Roscoe pod, and now those Packer templates are available. But if you have a pretty dynamic set of Packer templates, then you need a sidecar container to continuously load them into Roscoe pod. You would want to continuously load them because Roscoe is not quite HA right now. So what happens is if you have to restart Roscoe and there are running bakes at that time, it's going to terminate those bakes. and resources will be leaked, so you'll have to clean them up later on. So something to keep in mind. All right, so here's an example of the UI, and then if you're going to use a custom packer template, you have to go into that Show Advanced Options, and under the template file name, that's where you're going to put your new packer template. And then the user variables, the values that you need to pass into Roscoe, those would go under the extended attribute section. All right. So what is this for? So this actually is a Puppet. So if you use Puppet at all, couple of things to keep in mind. Well, the first one, it's not really Puppet specific, but whenever you bake that VM image, make sure that your service is not running, because sometimes it's not really gonna run, especially if it needs some endpoints. So what we've been advising our users is that, just install the binaries and then have a system start script or init start script that will just start them up upon boot up, not necessarily through the baking process. And then I think with Puppet, it allows for the Puppet masterless, and with the Puppet master. With the Puppet masterless, another thing to note is that it needs a copy of those Puppet manifests together with the Roscoe pod. So similar to the Packer template strategy, you will need to load them up before you start the Roscoe pod. Otherwise, another way to do it will be via the shell script provisioner of Packer. All right, some deployment tips. So for those who are used to deploying into the bare metal world or on-prem, where everything is static, just a note that in Spinnaker deployments, everything is ephemeral. You get an ephemeral IP and you get an ephemeral hostname, right? So if you need a stable network identifier, you'd have to use load balancer and DNS records. Or another way to circumvent it is you can have a Terraform stage that will do the deployment instead of Spinnaker doing the deployment. So unfortunately, not all of the features for creating a VM is available yet in Spinnaker. So for example, like if you need to attach a persistent disk already, so those are not yet available. So you'll have to do it the Terraform way. And then, but using Terraform doesn't come for free at all as well, because there are some things that are already available in Spinnaker. So for example, in the AWS world, you'll have to share the launch firms for that AMI to launch that VM. So for Spinnaker deploy, it already happens automatically behind the scenes. But if you're using Terraform, you'll have to go back during the baking stage, wherein you have to share that VM within your account. So remember, I was showing earlier about the multi-Packer template. You'll have to use that and share that AMI with, again, the account that you're going to use for deployment. Ideally, like all of the VMs will have to use the same configuration, right? But that's not reality. In reality, you still need to customize and initialize those VMs upon bootstrap. So the way to do that is via the use of user data or metadata. So that terminology actually differs by cloud provider. AWS uses the user data, and then GCP uses metadata. So in AWS, you can do it globally by using that user data file and putting it in cloud driver local, and you can also override it per deploy stage. So here's an example of a UDF file wherein it generates server and file, and with all of those tokenized environment variables. Again, you drop it into that cloud driver local file for configuration. So now, once you have that, every VM that gets launched will have that environment file available in the VMs. Now, for GCE, You can only do it per account. There's no global setting. So you do it via Halyard's Google command, -- user data, or you can just manually go into your Halyard config file or the Cloud Driver local and add it into the Google accounts list. And like in the AWS, you can do it per deploy stage. So here's a sample. We're in for that account, use that user data file. All right, so here's an example of how it can be overridden in the deploy stage. So with Amazon or AWS EC2, it's pretty straightforward. For GCP, at first we thought it was just a key and value pair. But I'm like, no, we can actually create scripts and put it in there. So after multiple iterations and experimentation, we figured it out. We can actually have a script, encode it in base64, put it in the user data key, and then have the encoding set to base64. So some of the best practices that I want to share today. So first one, I think it's the most important one, do not bake secrets. Please, please, please do not bake secrets. If anything at all, I hope that's the one thing you take back. Second is if you're concerned about the performance of the baking process, if it's taking a long time, you can actually chain multiple bake stages in Spinnaker. So you can layer bake stages. So you can do it a couple of ways. You can do it organizationally. So for example, you have your OS team, and then you have your applications team. So each one of those would be its own stage. And then say the monitoring team wants to add more agents in it, then there's another big stage. And then if you have another security, system security team, then they can do the hardening part as the last stage. So that's one way to do it. Another way to do it is similar to the Docker layering, right? Wherein you put the most frequently changed stage towards the end. So you can skip the first few parts and just keep on baking the last step. So I talked about in the GCP user data, metadata, right, and in AWS as well. One standard way of doing that, especially if you're going to deploy to multiple platforms, is to use the cloud config file. So cloud init is the service that runs in the OS during bootstrap time and loads that user data or metadata and then runs those scripts. So it's very powerful, right? Because now you just have one set of scripts that can run on those platforms. Another best practice, right? Enough said. Okay, one thing to note in Spinnaker is that there's a current limitation of about 1,000 images in the cache. So make sure you do periodic cleanup, because otherwise, like find image stages would fail once it goes past the 1,000 limit, and also takes up space, and you know, for every space you use up in the cloud, you have to pay for it. So, all right, and just like everything else with your application configuration and all that, Packer templates and the cloud config scripts, please use CI/CD for them as well. Those need to be tested before being rolled out to production too. All right, couple of tips for troubleshooting. So here we have the big execution screenshot. Just a couple of links. Don't worry about the old UI. Just want to highlight 2 links here, the source and the view bakery details. So those are your best friends during debugging. So the view bakery details will show you the logs that you got from Packer on how the bake is going. And then on the another log file that you can take a look at is the Roscoe logs. So in there you can actually see the Packer command that's going to run. So that would be helpful. And also, if you log into Roscoe Pod and you go into the temp directory, you can see the Packer log files there. Although note that these Packer logs are actually ephemeral. Once the Packer job completes, then they get deleted. So one way to go about it is to run the Packer command manually and add the debug command or debug option, debug flag, so that you can tail those log files as it goes along. And then this debug option also allows you to like step through each stage, so you can like pause and look at things before you move on. All right, so on the deployment troubleshooting, is kind of a hard thing because you're not just working with one VM, you're actually looking at all the different infrastructure pieces, all of the different cloud resources. So you have to look at a lot of the places for you to figure out where the issue is. But these are the things that helped us out the most. So when the deployment is not going well, we look at the SSH logs. So usually in the console of the cloud provider, there would be links to the logs. Also look at the instance groups, or in EC2 World, ASG activity history. Also check if your actual images and AMIs are shared with your account, because sometimes it's just a perms issue. Look at the compute instances that get generated. And this one is important as well, because sometimes you're actually over the quota, so that's why it's not deploying any more VMs. So check on that too. Going back, again, permissions, policies, roles, and instance profiles. Double check, triple check, make sure you have the right SGs and all of that. Again, these are all the other cloud resource settings that you can take a look at. So you have the load balancers, firewalls, VPC, subnets. It's a complex world. All right. So last but not the least, for contribution ideas on how to make VM image baking and deployment better in Spinnaker, I have a few suggestions. So one would be baking HA, so for Roscoe, to handle restarts of Roscoe so as not to impact currently running bakes. And then extend support for the different cloud providers. Again, we have some basic things in there, but it could be improved. For cross-cloud baking, if we could have non-SSH options, although I think this is more of a Packer contribution rather than Spinnaker, but it's still VM image baking, so that's. And then dynamic Packer template loading. Again, you have to create your own init container and sidecar container, but if we can contribute back to the community for Roscoe to just handle it automatically for us, then a lot of organizations who use VM image baking would benefit from it. And then VM image promotion and distribution. These are kind of being solved right now with Kill, the managed delivery. If you didn't attend talk about it yesterday, then please watch the recording. It's exciting stuff that will solve some of those problems for us. And then I've also listed links to all of the other open issues with regards to, again, VM image baking and deployment. All right, so with that, again, thank everyone for coming over. Thank you for time, and I appreciate it. So questions, I'm also, you can also see me in Slack, spinnakerteam.slack.com. So I ask a lot of questions there too. So please don't be shy if you have to ask me questions. I also shared my email address.
Anybody have any questions? I can probably speak loud enough. You mentioned the bake cache. I'm not too familiar with that. Do you know what gets put into the hash for to?
Yeah, so the top of my mind, I think it's the package. There's a package field in the UI that's used as one of the keys, and then there's the OS.
Is there any versioning info
on your package field. Usually you'll supply what version of the package you want to deploy.
Okay.
Yes.
So do you use Spinnaker to roll out your VMs too?
Do we use Spinnaker to roll out our VMs too? Yes, we have some use cases that use VMs. We have the simple ones and we have the complex ones, so we have to study both.
See, what like I read blog post that was suggesting to not use Roscoe for creating the images outside Spinnaker, like in Jenkins, because of it takes a long time waiting Roscoe. Do you know anything about that?
No, I'm not aware. Sorry, we use Roscoe for our baking.
Maybe the cache will help with that.
Probably. It all depends on your provisioner steps, right? The more complex your provisioner steps are, then the longer it's gonna take. So one way to go about it is to split your bake stages into multiple steps. So that's how it can be fixed as well.
And for us, in particular, it doesn't work because we are multi-cloud. So our CI actually runs in first party right now. We don't even run it in the public cloud, and it produces a set of images that only inherit. It produces document images because they can be the same for everywhere, but VM images obviously that don't work. Which is why we do need Roscoe for all the target clouds we own.
You have mentioned the 1,000 images limitation in cache. Could you elaborate on that? Like, is it per account or what is it doing?
Yeah, it's per cloud provider is from what we've noticed. So for example, we have multiple regions and we would look at one region and we're like, well, this only contains like about 300. Why is Spinnaker Cloud Driver now failing? So we would go and look at all of our accounts, and when we tally them up, they're actually more than 1,000. So we have to go clean them up across the different regions.
So is it like a limit on cloud driver? Can it be scaled to handle more? Or?
Pretty sure there's a bug file working on that one, but yeah.
It is on Cloud Driver.
It is on Cloud Driver and the Redis cache.
We increase the number of connections, the Jenkins connections. It was hard for it to find it all. So that's one of the advantages now. So it's kind of like hard is the wrong way to say it. It's the file configuration is 100, and then we need to increase that. So sometimes the driver is now releasing all those connections. So the 1,000 was a reference number that we get that we discovered that we would have exhausted all those connections. So we need to do more testing on it. First of all, use the connection to do it, and also see how it's reflected again in the number of images. But I would say best practices why we have so many, images of that.
So do you create a new image during every deployment?
Do we create a new image for every deployment? Ideally, we'd like to, but it would depend on the eventual scale.